All right, on this problem, we need to write a ratio as a fraction in lowest terms. So we need to do 36 to 32. So we're writing this ratio as a fraction. So I'm just going to follow those directions, write it as a fraction. So 36 over 32, but it needs to be in lowest terms. So I need to simplify this. Basically, I need to find a number that goes into both 36 and 32. Well, the first one that comes to mind is 4, so let's go ahead and divide both by 4. 2 also does, but I always want to find the biggest. So 36 divided by 4 is 9, 32 divided by 4 is 8, and I can see that's as far down. Oh, if I wrote 4 and I said 8. There we go. So 32 divided by 4 is 8, and so we can see that's the lowest it's going to go down. Okay, on this problem, again, we need to write the ratio, but this says a ratio of whole numbers in lowest terms. Well, I know it's going to start as 0.30 to 0.40, but it also says these need to be whole numbers. Well, to get the 0.30 to be a whole number, I'd have to times by 100. But we know if we multiply the top by something, we have to multiply the bottom by the same number just to keep that value the same for the fraction. So we multiply those. This makes the decimal move over twice, so I get 30 over 40. Okay, so we've got the first part, we've got it as whole numbers, but we also need to have it in lowest terms. So what's something that goes into both 30 and 40? I'll admit those zeros are just staring out at me. So I'm going to cancel out the zeros, or basically it's like we're dividing both by 10. Because again, we always want to do the same to the top and the bottom in the fraction. And so we get 3/4 for our final answer there. Okay, here we need to enter the ratio as a fraction in lowest terms. So I'm going to have 3/17, 2, 1, and 7/17. So what we're going to want to end up with as a final answer is just a fraction with a numerator and one denominator. So we're going to have to simplify this. So first, I'm going to work on the bottom. Let's make the bottom, the denominator, into an improper fraction. So I'll still have 3/17 in the numerator. I'll do 17 times 1 is 17, add the 7, and I get 24 over still 17. Okay, now, if you remember, this is basically the same thing as saying 3/17 divided by 24/17. When we divide fractions, we need to flip the second fraction and multiply, so multiply by 17 over 24. So what we could have even done is at this point we could have just multiplied, if we remembered that trick, just multiplied the top and the bottom by 17 over 24. And it's the same exact thing, okay? So these are just kind of two different ways to think of it. So since I started over here though, I'll do this way. So the 17s, I'm going to cross cancel. I can see those are going to cancel each other out. I'm just left with 1. The 3 goes into 3 and 24, so I can divide a 3 out of each. 24 divided by 3 is 8. Now I'll multiply across. 1 times 1 is just 1. 1 times 8 is 8. So my final ratio in lowest terms would be 1/8. So really, you're kind of getting a complex fraction that needs to be broken down here. Okay, Superman needs to save Lois from the clutches of Lex Luthor. It takes Superman 13 seconds to get to Lois, who is 676 feet away. What is Superman's rate? Well, how do we know what's on top, the 13 or the 676? Well, here's our clue right here, in feet per second. So that means feet come first, per second goes on the bottom or the denominator. So I'll have 676 feet per 13 seconds. Now I'm going to pause this and let's see if that divides evenly. And it's our lucky day. It does divide evenly, so just 52 feet per second, which we don't have to write out because it's labeled here. But if it didn't work out evenly, I'd be looking to see, is there somewhere it says that I need to round to the 10th, or just put it into lowest terms, you know, as simple as the fraction could go. But in this case, we don't have to worry about it because it works out perfectly. Okay, on this one, we are comparing window cleaners. It's so funny. I use this exact concept often when I'm shopping. I used it today. In fact, I was at the store today and I used it to compare two different walnuts. I was looking at a bag of walnuts versus like a packaged walnuts, and I wanted to see which was the better buy. So we basically want to find out the cost per ounce, right? And that tells us how we set it up. If we do the cost per ounce, that tells me I'm going to do $3.34 per, so that cost per 17 ounces. Or I'll have $2.58 per 13 ounces. Okay, I used my calculator, and it's funny, the first one, I rounded it up to 0.20. Well, I saw when I did the second one that it would also round to 0.20, that I would need to find more decimal places. So this one came out to be 0.196, so I'm not going to use that 0.20 because it wasn't exact enough. The other one came out as 0.198, so because this one is smaller, I can see this is a little bit cheaper than this one because of that 8, so this one would be the better buy. Okay, so the 17 fluid ounce for, there we go, 19.65 cents per fluid ounce. So that's the answer that we got. Okay, for this one, we again need to find out which is the better buy. So we have 6.59 for 16 ounces or 4.99 for 12 ounces. So again, we want to find out our cost per ounce. This gives us the unit price. So we'll do $6.59 divided by 16, or we have $4.99 divided by 12. So I'll do this on the calculator. Okay, so I calculated each of these on the calculator. 6.59 divided by 16 gave me 0.411875. Because this was the first one I did, I took it out a lot of decimal places. Now this was the second one. As soon as I could see a digit that was different, so 0.41 was the same, but I saw this 5 right here was different than this third digit, I knew I had enough information. So which one is the better buy? Is it this one that's 0.415? Or is it the one that's 0.411? Well, it's the cheaper one, right? We want that one that's a smaller number. So the 6.59 for 16 ounces would be the better buy. So whenever you're trying to figure out better buy, you want to figure out the unit price, make sure you take it out enough decimal places, and then you can compare.